Welcome to Mikab Model College online tutorial. We hope at the end of this lesson, you will have acquired the expected learning outcome. Sit down and listen attentively as we introduce your subject teacher.
Welcome to chemistry class. I am Saliu Abdul Wahab, your chemistry teacher. In this class, we shall be looking at the composition or the constituents of an atom. Remember in our previous class, we saw the modifications of the Dalton's atomic theory. Now let us look at what does the atom actually look like. How is the atom arranged so that we will have a better idea about an atom. Of course, the structure of an atom shows that an atom is made up of two parts. The structure of an atom shows that an atom is made up of two parts. These two parts are the central inner nucleus and the outer shells. Of course, the nucleus is right inside the atom, while the outer part, which is the shell, surrounds the nucleus. Looking at the diagram on the board, the first diagram illustrates the inner parts of an atom. And the inner part of an atom, which is known as the nucleus. Look at it. This is the nucleus. The nucleus is made up of the protons and the neutrons. Therefore, as a chemist, when asked, where can we find protons and neutrons in an atom? Both protons and neutrons are inside the nucleus, and the nucleus makes the central part of an atom. Now, around the nucleus, you will see some spherical shapes around the nucleus. These spherical shapes are in constant motion. Constantly, they are moving around the nucleus of an atom. Look at it. These spherical shapes are called orbits or shells. Orbits or shells. Now, when you look at small, tiny circular shapes on the orbit, there are three of them here. This represents electrons. So on this note, protons and neutrons are inside the nucleus of an atom, and the nucleus makes the central part of an atom. Around the nucleus, we have orbits or shells, and on these orbits or shell, we have electrons arranged. The second structure shows us that the nucleus is dense. The nucleus is dense, and it represents the protons and the neutrons. And of course, look at the orbit or shell. In the first diagram, the orbits or shell are shown to be revolving around the nucleus, while in the second diagram, it shows how electrons are arranged either singly, as in the first shell, or in pairs, as in the second shell and in the third shell. Now, all the small circles you see arranged on the orbits or shell are called electrons. Now, this is the structure of an atom. Now, an atom consists or composed of three subatomic particles, which are, just as we have seen just now, protons, neutrons, and electrons. The order in which they come does not matter. It could be protons, electrons, and neutrons, shortly abbreviated as PEN, where P is proton, E is electron, and N is neutron. The proton and the neutron are contained inside the nucleus, as we have just seen, while the electron rotates constantly and continuously on the shell around the nucleus, as we have just seen. Now, as a kind of exercise, name two main parts of an atom. Let me guide you. An atom is made up of two parts, which are the inner central nucleus and the outer orbits. And of course, remember that the inner central nucleus is made up of the protons and the neutrons, while the orbits carries the electrons. Now, from there, let us quickly look at the relative masses and electrical charges of the subatomic particles. Having known that an atom is made up of subatomic particles, which are known as the protons, neutrons, and the electrons, let us look at their charges each and their masses each. The relative atomic mass of proton is approximately equal to that of neutron. Don't be surprised. The relative atomic mass of proton is 1. It is 1. And equal to that of neutron, which means that neutron is also 1. The relative atomic mass of proton is approximately equal to that of neutron and is equal to 1. But the mass of electron is very, very small. Very, very small. And the mass is highly negligible. That is 1 over 1,840 that of a proton. That is, it is 1 over 1,840 times smaller than a proton. The table shows particles. And what are those particles? Proton, electron, and neutron. Then we have the relative masses of each of the particles, the charges of each of the particle, then their symbol. For proton, the relative mass is 1, and the charge is positive from the term proton. Proton means positive, and the symbol is P. For electron, I told you that electron is 1 over 1,840 times smaller than a proton, which gives us 0.000544, and the charge is negative. For an electron, the symbol is E minus. While for neutron, the relative mass is 1. And remember, I told you that the mass of a proton is equal to that of a neutron. And the term neutron means neutral. Hence, neutron has no charge, and it is regarded as neutral, meaning it is neither positive nor negative. And the symbol with which it is represented is N. Now, as a kind of assignment or exercise, list 3 subatomic particles and their charges. To guide you once again, the 3 subatomic particles of an atom are proton, electron, and neutron, that is PEN. The charge of a proton is positive, that of electron is negative, and that of neutron is neutral, meaning it has no charge. On this note, we have come to the end of this lesson, but mind you that when we talk an atom, you need to be aware that an atom is made up of a central nucleus that contains the protons and the neutrons, while it also has orbitals or shells on which electrons are arranged. Of course, the proton, which is positively charged, the electron is negatively charged, and the neutron has no charge. Thank you very much. I hope you do subscribe to our channels. Thank you.